Now I'm sure you must have like this panorama mode on your smartphones. So when you go to a place and you try to capture this image in 3D, now at a time the phone is looking only in one direction, right? But what it does is when you move the camera, it stitches the image on the left with the image on the right, and we are able to obtain this panorama kind of an image. Now, how does this happen? How does it know how to combine this image on the left and the right? Now, what happens is that it tries to. Now, let's see. For example, we have to stitch these two images, right? Now, these are a bunch of numbers on the left and on the right. Now, there are some algorithms to identify the interesting. This is, for example, I told you how we can identify edges, right? Similarly, there are algorithms that have been formed that help us to identify corners. So let's say for this particular mountain, I can get these interesting points, interesting corners where some interesting changes are happening between the pixels. Now, for example, let's say from the left and the right image, I'm looking at the sky. Now the sky was blue on the left and sky is blue on the right. I don't know. So it's hard for me to tell which part of the sky on the left is corresponding to which part of the sky on the right. But for mountain, I can say, because I know the top of the mountain on the left is somewhere and top of the mountain on the right is somewhere. So now I know where the same point is changing. That the mountain has shifted to the left. I can say that. For sky, I cannot say. So with some computer vision algorithms, you can identify these interesting points like the peak of the mountain, such as corners, in both the images. And now once you know that, for example, top of the mountain is same in both the images at these places. So all these white dots, small dots that you see, the computer vision algorithm has identified these interesting corners in this image. And it has identified these same corners in the right image. And once it knows where are these, then it can take the right image, put it on top of the left image. And that's how it kind of folds this image and puts it on the left image. And here we are able to like form a stitch of and form a panorama. So this is what these algorithms do. um, okay, awesome. Yeah, maths is beautiful, right? It allows you to understand these matrices. um, so I hope you get a general sense of, obviously I cannot go in these algorithms in very detail, how are these corners found. But if you're curious, you should be able to now figure out by looking up some material. uh, so these are algorithms which try to manipulate these image matrices to obtain these important features and do these interesting things like finding corners and stitching images. So is this somewhat clear? Like, are you able to understand how things work? Any questions?
Yeah, so it's clear.
Okay, awesome. Yeah, so this was basically the hardest part of the talk. If you understood it, uh, that's great. I mean, this was a successful session for you. So now you understand that we can manipulate numbers. I know I keep saying this, but this is the beauty. Like, you need to understand how to manipulate numbers in matrices, and math allows you to do that. So all these topics that you're studying in school, like integration, differentiation, you know sometimes you wonder, why do you do d by dx? What's the point of doing that? And you figure that out like after a few years after doing college. So scientists, before all this era of deep learning and neural networks, scientists came up with these methods. Okay, so again they tried to learn from how humans learn. So how humans learn is that, for example, if I show you, when a kid tries learns how what a zero is, what one is, it sees a lot of zeros, right? This kid goes to kindergarten, and they are taught about, this is what a zero looks like. You make this circle kind of a thing, and that's a zero. So the kid draws like hundreds of zeros, sees a lots of zeros multiple times, and then they learn that it's a zero. So similarly, scientists thought, why not we teach computers in the similar way? So what they did is that they collected lots of data. They collected hundreds of images for zeros, ones, twos, threes, fours, and so on. Now we have some data set. This is a very famous data set. It has propelled a lot of research in computer vision, and it's called MNIST. Okay, so once they collected all this data, then they said, okay, now we have to teach machines using this data. Now, if you see this image of a single zero, for example, then it's a very simple image, right? It's only black and white. So it's like 0, 0, 0, 255 suddenly, then 255 for another pixel, then 0 again, then 0, 0, 0, then 255, then 0, 0, 0, 0, and so on. Okay, so it's just a very, these are very simple images. Now, again, so now we know these are numbers, matrices of numbers of zeros and ones. And and how do we understand if they are zeros or ones? So what we do is that we take this image, we calculate some important features from it. Now, what do I mean by important features? So like I showed you that in an image of a mountain, the top of the mountain is an interesting feature. In a similar way, the edges and the corners that you find in any image are interesting. So it gets all these edges and corners. How does it get all these edges and corners? I taught you that using filters. So there are different filters and algorithms to find edges, corners, and interesting features. So you do that in the first stage. So for example, if you see, let's say, two circular type edges and some rectangles, so it's likely that it's a car, right? I mean, if there are, let's say, 100 such features and they are occurring in all car images, then it's probably a car, right? So there is something. So in machine learning, you first of all have lots of data, then you get lots of interesting points from it, interesting features such as corners, edges, and these things. And then once you have those, then you assign a label to all these images, and then you pass them through a machine learning model. And what does a machine learning model do? So we in machine learning, you can think of machine learning model as a machine. Okay, the machine gets 1,000 images of zeros, and it calculates the features from zeros. So it tells it that in each row there are, let's say, two edges, and it passes that to machine learning model with a label of zero. And then there are 1,000 images of one. So, and the interesting features are that there is just one edge, and then it feeds all that data with the label one in the machine learning model. Now, what this machine learning model does is that it uses mathematics to identify patterns in these two different kinds of data. And these machine learning algorithms, they are able to identify the pattern to classify it as a zero or one. And so the machine, so with so much data, the algorithms automatically identify that if there's only one edge for a certain amount of vertical strips, then it means that it's a one. And if there are two edges, then it's probably a zero. So this is like a very simple case, but actually, like, you can build more complex and complex machine learning models using mathematics to help it identify all these different categories from 0 to 9. So this is how things were done. Now, how does research move forward? They try to think of the limitations of their current approaches and how we can do better than them. Okay, so machine learning effectively, it allows us to see and understand patterns in data that naked eye cannot. So, for example, here it's very easy for naked eye to understand what's the difference between 0 and 1. But when it's so many different kinds of cars, it's not as simple as saying that there's a one edge and a one corner. It's a bit more complex than that. Car can have different illuminations. Car can have different objects, different structures. So what machine learning does is that even though you might not be able to identify the pattern exactly, it gives you a mechanism to understand the shape, understand these patterns without, it always being visible to the naked eye. So we just feed it a lot of data. We feed it some labels, and we hope that it will give us good results. The problem with these techniques is that they are not really artificial intelligence, because we are still finding some corners and edges manually, right? So we are trying to tell it to find corners and edges, but so this was leading to identification of zeros and ones, for example, but it was not as good as humans. Humans were still much better than it. For, like, there would be some images with like two edges, and for example, the computer might see an image of a wheel and it would say it's a zero just because it's a circle. but that doesn't make sense, right? It's a wheel. So the problem with that was that we are explicitly trying to give it, enforce it to learn things based on based on man-made features such as edges or corners. But why somebody thought that why don't we figure out a way in which the computer can itself identify what are the important things to look at? So that would be zeros. So instead of like humans telling it, okay, find edges and now find do apply machine learning, I will tell it to find anything that you find interesting and then apply machine learning on it. And that is the beauty of neural networks. So what neural networks do is they they automatically extract the important features that might be relevant for the task. So for example, if I have to differentiate between a cat and a dog, then I don't have to explicitly tell it that you should identify, look for ears first, then look for mouth, look for tail, and then based on that structure you should identify if it's a cat or a dog.
Can you
I
explain neural network again? I lost my connection.
Yeah, sure. I haven't like explained neural networks, but I'm saying the idea is that instead of having to instead of asking the computer to identify explicitly the edges and the corners and then use those to uh, and then use those uh, to do the task, I'm saying that you find whatever you want, whatever you find interesting, and then use it to identify it as a cat or a dog. And the way that neural networks are modeled is on human brain. So the way that human brain works is that there are several different connections. You can think of it as many different cells called the neurons, nerves. So these are cells of the neuron system, and they all conduct electricity or conduct some. They all pass on uh, some impulse, as it's called. Um, so they pass on some signal basically, and all these. So there are thousands of neurons, and they're connected to each other. So let's say when on our retina red light falls, then it generates some sensation. So one neuron is, let's say, generates some red red sensor red sense signal. Then it passes that to the next neuron, and the next neuron passes it to the next neuron, and there are like hundreds of neurons connected to hundreds of neurons. So these are all branching like a tree. Now the thing is that it how it works is that when it's, let's say, it red light falls on the retina, then some of the neurons fire and some of them do not. It's like electricity. So some of them pass electricity and some of them do not. And based on this pattern, the brain knows that it's a red color. So when green color falls, then different set of neurons fire. Different set of neurons conduct electricity. And brain knows eventually that what's green and what's red. So similarly, mathematically, this guy, Geoffrey Hinton, he's called the father of neural networks. So what he did is that he found an algorithm to for computers to model what happens in with neurons. So when it sees when the sensor sees red image, then it's connected to a neuron, and those neurons are connected to 10 neurons, and those neurons are connected to 10 neurons, and ultimately it the brain perceives it as a red or green. So similarly, the computer vision algorithm perceives it as red or green. I know this is very abstract for you to understand right now, but I'm just telling you the gist of it. To really understand it, it would require you to, understand some math, uh, develop some intuition over time, explore on your own. But I'm just telling you the gist of it, that neural networks is basically a machine learning algorithm that tries to identify what's important in image on its own, and it works based on how your brain works with a network of neurons. I mean, I know probably this is not very clear, but I would say just know the gist of it, and then eventually, as you study more, you'll figure it out. So what happens is that instead of for example, I have to identify this car. Instead of I tell it, so earlier what was happening is I would tell it to identify wheels. I would tell it to identify windows, and I will say if you find these guys, then I classify it as a car. But now what I tell is that I just connect this image of the car to 10 neurons. Those 10 neurons are connected to 20 neurons and so on. And ask it to tell me if it's a car or not. So what I do is that I collect 10,000 images of cars. I ask the neural network to calculate some features from this car by doing some. So what neural network does is, so for example, earlier what we were doing is we manually defined a filter to calculate edges, right? For example, 1 to 1 to minus 1, 1 to minus 1, 1 to minus 1 is one filter to get some kind of features from the image. Now I'm going to initialize it not with specific numbers, but with random numbers. So right now it doesn't know anything. It multiplies these random numbers and it produces an output saying that it's a car. But what I tell it is that if let's say I pass it an image of a car and it says it's a car, then I say you have done a good job. But let's say if I pass it an image of a car and it says it's not a car, then I say no, you are doing something wrong. So what it does is it changes the weight of its parameters, and it tries to calculate, and then again it tries to tell me by doing some calculations that it's a car. Then if it's a car, then I'll say good. If it's not a car, then I'll say you need to change it. You need to change your parameters. So eventually when I train it over 10,000 examples of car, then it learns how to identify cars, because now it has learned these features in its layers that can look for the things that are important for a car. So for example, if you see this second image on the bottom, it shows on the left side an image of a wheel, right? So this algorithm has automatically found that it's important to identify a wheel to classify it as a car. Now there is an important thing about ethics also. So sometimes, because these algorithms are learning from data, right? Now what happens is that often, for example, the data sets only have, let's say, white faces and less black faces. So what happens is that the algorithm does not detect the faces. So early on, because of the fault in collecting data sets, this computer is not, let's say, identifying this black man's face. Okay. Oh, not identifying it. Okay. But as soon as this white woman comes in, the computer is able to know where her face is and it's zooming there. And you will see that whenever the black man comes in the frame, the computer, it's unable to identify that person. And that has happened because of the bias in the data. So now you see the black man is in the frame, so the computer is not detecting anything. It's not zooming into him. But as soon as the lady comes in, it starts tracking her. So this is what happens. And like, because you are young students, I want you to like be aware of this right at the start. As you're like studying, like it's important while building technologies, it's important to like think about ethics and build things in an equitable way, so that no section of the society thinks that they are missing out on, so that these technologies have been built by not keeping them in their mind. So deep learning has allowed us to do so much, because it just goes out and figures out what's important for it, that we are able to do so many interesting tasks. So for example, we give it this image, blurred image, and we tell it that this is the sharp image, and we try to train this model over and over thousands of examples. And what ends up happening is that it learns how to de-blur these images. Then we are able to make these new paintings in different styles. For example, there's so the small rectangle that you see, it's a painting, and then we can convert any image into that style of painting. So people have come up with all these creative ways of doing things. So like there's something called GANs, generative adversarial networks, that allows you to do very interesting things. So I can show you this video. So now you see, so the source video is actually the video of a real human being dancing, and the right one is actually fake video. It's being generated by computer. So uh, this video, this dance is being, so this is completely, so this is like completely synthetic. So whatever dance we are doing, recording in the source video, the computer automatically generates a video for the target. And so you can do all these kinds of different interesting creative things. Okay, now this is very interesting. Like this recently came out. So I asked the algorithm to generate an image of Pikachu in pajamas watching TV. Now, no such image exists on the internet, but this algorithm has now understood what Pikachu is, what does wearing pajamas mean, what does watching TV mean, and by seeing so much thousands of data points on the internet, and it generates these interesting images. So, all in all, computer vision is a very multidisciplinary topic. There's artificial intelligence, machine learning, and robotics, as we understand, and then there are all these different, because you need to understand brain, how to understand how to model artificial intelligence. So cognitive science, neuroscience comes in. I've told you about image processing, how we process image matrices. That is important. Computer graphics is important. So like it's a very multiple disciplinary fields, and it's like uh, very interesting to work on it, because you get to learn not just about computer vision but about so many other topics. Yeah, so that was my talk. And yeah, most of this knowledge I've learned from Professor Carl von Wright's course while my master's in Columbia. um, so yeah, just I wanted to acknowledge him. um, and yeah, I mean, I know it's already late, but if you guys have any questions, I'm happy to take them.